Let's do little changes for the lighting before we continue rendering. So I will just bring this up and I will bring this down. Let's see here, that's good. Now we have a little more dramatic lighting, and also we can do one thing which is important. I think we can just select all the lights in the scene just by going here, selecting all the lights. I can select all the lights and I can group them. It's just to ease everything. So I will say lighting setup, and all I need to do is to change their position always. So sorry, I have to include this one to the group by attaching this here. And now all I need, if I need to change the lighting, all I need to do is to rotate or scale or do whatever I want. So that's good. Now we moved with the whale, and we can just render any frame like this from here. Let's go a little more here. That may take a few seconds, but again, now we are getting closer to the lighting setup we want, and I think we are ready to add some shaders. So let's add one material, and it should be the ocean shader. And all we need to do is to make sure this is black and this is white. This is typical shader for the water, and this is white also, which we may change later to reflect better lighting when we are above the scene. And also we can make sure this is 1.33, which is the water. I will adjust background so we see the water, and for here I can add some fog color, which gonna define how is the color of the water and how we see the water when in depth. So I can just increase this to here, take some greenish bluish color, that will do the trick. That's good, and maybe I'll decrease this to, that's good. So that's it. And to see this, we should bring this into 0.01. Nothing else. Sometimes I change this into billion. You can change it back if the effect is not good, and all you need to do is to select this and add this here. That's it for now, and let's try and render. That's cool. We can see that we have the ocean, we have a good lighting here, and we can see that it's showing us a good coloring when depth. And maybe we need to increase the light, but that depends on the view. Now we don't have really a good surrounding system. What I mean about that, it's we don't have really a sky to do the trick, but later we need to introduce another sky, and it should be HDRI so we see better presentation for the sky. Now it's just gray, and even if I will look at it from this perspective, of course we can work on it and develop it, but I don't think this is the best technique to get the lighting. That's just so limited. We need to introduce HDRI light, but for now let's just stay working, continue working on the particles and introduce them, because until now we can't see the particles. So again, based on the depth of the object in the scene, how far it is from the camera, we will choose the kind of shading for all the particles. But before we do anything, I will create some shaders. I prefer to create them here, not to accept to create them automatically with the container, to show you exactly how you can create them. So to create the shaders, all we need to do is to create, and here we have Phonics FD foam. So I'll create one here, and I'll create another one which can be it doesn't matter where they are in the scene, but the first one I will call it shader 1 foam, and the second one I call splash, And we can choose the container here by going here, and because it tells me, do you want to also set up the simulator liquid in the liquid simulator slot of this shader? I will say yes, then I will change it later. Now it will display all the kind of particle system for this in this container, so I can choose the splash between them. Let's wait a little. So now I will choose the splash, and that's it. And here it's point. This is what I want, point. Sometimes it comes by default splashes. I wanna change it to point. Now this also the same. I will choose the container, and I will say yes here for this message, and I will choose the foam. Again, it's point, and this is what I want. Now we can go very fast here to see what is good about this system rendering with Phonics FD shader rather than rendering with Krakatoa or other point rendering systems. Shortly, this is the best as I saw, and you can really accomplish very good timing for the rendering. The parameters are simple to treat and everything. There are some parameters like the size variation, size distribution, and size multiplier, which you can update or change the basic settings you put here for these particles in the simulator when you started introducing the foam and splash particles. So these enable you to change whatever you put initially in your simulator. Now the color is the color, and sometimes we just change this a little. We introduce a little bluish color for the foam as example if needed. We will know about that later. And here the diffuse multiplier, it controls how the particles color or brightness interaction with the light. So I can reduce this number if they are so shiny and increase it if not. Size, I can change their size, but the basic or the main controller for this, because I'm rendering points, is here. So the points, the main two parameters to change is the point alpha and the point radius. And as a very important rule here, you can see is in pixel, means if the scene is big or small, the object is close or far, that's in pixel. So we may change this number dramatically sometimes to see the particles. And I will always start from the default and develop it. For our scene with the scale and our scene, everything seems good with the default numbers. For the point alpha means that it will introduce an alpha for each particle, and that's important because if you increase this alpha means the particle will be clear more. And one important note here is that you need to have the alpha effect of each particle by accumulating particles better than introducing stronger alpha here. So what that means, if we increase the number of particles, that's the best solution always. Sometimes you can solve it by increasing the point alpha, which gonna make it clear more and obvious, and it gives it a presence in your scene. But again, I always prefer to introduce much more particles and have them accumulating their alphas to introduce better alpha. So we will start from the default here. Another thing is the motion blur. I can introduce motion blur by going to force on. We will see that later. Other than that, already the particles will get some colors from the ocean. So if they are under the ocean surface, they will get color defined by this color, and that's extremely good. If we compare this to the technique in other programs such as RealFlow, in RealFlow, if you want to render these using Krakatoa as example, you need to render the particles under the sea and the particles above the sea and shade every one of them alone. For now, here in this Phonics FD shader, you don't need to do that. It's automatically created here by just defining or introducing the simulator here. So I choose it here and I have it now. So automatically Phonics FD will recognize which are the particles under the sea and which are above the sea, and will shade them, introducing some of the color of this, like the particles or the foam particles under the sea should be darker or having some tint. Also, This is extremely useful because that will take in consideration the displacement of the sea. So again, when we simulated everything, the particles were generated knowing that the surface of the sea is flat. Now when we introduce the displacement, that means some of these geometry gonna go up. To push these particles up with the new geometry or displacement of the ocean surface, this is automatically happen here again. And this is extremely good because such a process in real flow will require us to re-simulate things or reintroduce these particles by snapping them into the new displaced mesh. This happens automatically here. This is a good advantage, and it's huge actually. Another thing, if you want to multiply the amount of particles, sometimes you have the particles but you need to increase their numbers, as we have here for the splashes. To do that in other programs such as in RealFlow, you can do that by multiplying their numbers. For Krakatoa, if you want to do that, you need to do a partitioning, which is a process which it's almost a simulation because you need to create particle between two particles, every two particles or more, but that will require a lot of work, a lot of rendering time. I would say simulation time because it happens before the rendering. And here in Phoenix FD shader, you don't need to do that because it's just a number. You can multiply it, make it bigger than 1, and it will increase the amount of particles, or just less than 1 and it will reduce the amount of particles, and it's extremely nice feature. Again, one thing to remember here is that new created particles are good, taking into consideration the original particle position, and they will just create some particles around it, like a cloud of particles. That is not replacement of increasing the original particles, because it will create something, but we can't go really far away, like 6 or 7, because that will just introduce particles as a cloud around our particles, not actual particles who are interacting with the surrounding simulation environment. So I would say I'll keep it 2, 3, maybe 4 if needed, but not more than that, and I prefer not to use it usually, but it's there if you need it. So we have that now, and for this also I'm introducing this as points. Why? Because in this scene we are rendering something from far, and it's large scene, it's a big scale scene. Most of the big scale scenes we render these as points. As you will see, in a closer scenes we will render them as bubbles or cells, like here, cellular, or even splashes, which are small spheres, and that will increase the amount of time for rendering. For us now, we don't need to worry about that because it's points. And here for this, which is the splashes, I have this activated. I actually don't need it to be activated here because most of the splash by definition should be above the water, so above the displacement, and we don't need to see them under the water, so this shouldn't be displaced. And usually we get a message if it's activated here telling you that you don't need it to be activated. I will save the scene and then start rendering. So before we start rendering, let me just take a look at the rendering setting, which is the simplest thing here. So I'm running Vray next. Of course, that applies with other versions of Vray, but here I'm using buckets and I'm just using 4 subdivisions. No global illumination anyway. And for here you can always add denoiser, which can enhance the noise pattern, and you need it to be mild, not much, but again think of it like that. So these are the basic settings. You can increase them as much as you need. So let's just render this frame. I need to look at it from this perspective. So we should now see some of the particles, because now we have shaders for these particles, which are going to be responsible about rendering and updating their shaders. So this is for the foam. Now it says rendering mist splash in point mode with liquid simulator specified will consume additional memory for this displacement. You may disable the liquid simulator option. This is what I mentioned before. We don't need to introduce the simulator here in the splashes. Let it go now and we'll displace it later. For now, as you can see, we have a good representation for all the particles, and we have the color here. The particles under the sea, they have good coloring. Everything seems good, but we have a little note which we have to take in consideration. As you can see, I can say that volume or the size of the particles is big, as well as they are so shiny. Means they are taking more colors that they should be, more lighting. So I can decrease the diffuse to 0.7 as example for both. I can go here and see the, here for the foam also the same, 0.7. That's good. Again, I would go to splashes and I will just deactivate this because I don't need it to be here as per the message. Other than that, I will just render to see if I will need to change other things. For the volume of each point, we don't need to change that from here, the size, although we can change it from here, but I would use the other parameters down to do that. Now we have a good, better presentation for the shading of the water than it was before. So I can just come closer a little, look at it from this angle and try to render again. Again, we can go down and change the point radius, but now we will have better idea about it. You can see here that this is so nice. These are bubbles, basically. They are the foam particles under the water. As you can see, we have a good radius for the particles, but again, we have strong alpha, which gives us here a solid white. Anyway, let's change this by going down here. This is mostly is foam, so we need to change the foam here. So by changing this down 0.07 as example, we are reducing the alpha of the particles. This is what we should see now. But remember, rendering time is extremely fast, as you can see here, and the main reason is the lighting setup, and we have millions of particles now. This worked good, but we may work more on it. Look here, we have some other details now. We can see more details, but again, I see that we may also go with the radio down just to 0.9 as example, or 0.8, and let's see what will be the results before we just start increasing or changing things. Also, we can't see any motion blur here. I will introduce motion blur and see it will not take time, and that's amazing also. Now for the whale body here, I made sure that we have full shading SSS added to his body. So with that included, with everything, we have amazing timing for the rendering. If we will change the scale of this image into HD, we will have something around 1 minute and something, but on average, without all these particles, until they are there, it's 1 minute, maybe more a little. So that's good. We can also introduce some motion blur by going here and enforcing the force on motion blur, and that's good. Also, we can define here the multiplier, so you can change it 0.7 based on the need. But again, if you are doing this with live footage in the background, that should totally depends on the camera settings of the footage in the background, so we need to take that in consideration. Now you can see that that doesn't really increase the amount of rendering time, but we still have some motion blur here, and in the areas which is moving a lot. That's good because that gives us the sense of motion, but it killed some of the details here. Anyway, when everything is moving, that will be really cool and you'll see it. Now look at this. This is amazing. We can see everything as expected. I will look at it from above, like here, and see what would be the scene. Remember, this is where all the particles are a lot here. We have a lot of foam particles. We will try to see it from here also when the whale is rising his head up. And as you can see here, we have a little problem which is related to the lighting. I would say the lighting is good. We don't have really a big problem with the lighting. The main problem we have here is with the surrounding image, which I would say the skylight or the Vray skylight. So now its body is up because it's sinking down. Let me just go here to this frame where he's rising his head up and try to render this. Just by changing the angle of the camera, we have more lights here, which is not exactly the kind of reaction. I don't need it to change a lot based on the camera angle, so we can just fix that just later. We will see about it. What we are missing now is the surrounding. The sky, Vray skylight doesn't really give us the control we need, and it doesn't take in consideration even the rotation when we rotate the sea view or anything like that. We'll go here, how the water is covering the whale. All these are bubbles, which is basically particles under the sea, which we name them foam. Here in this stage, the whale is rushing, if you remember, and we have some high leading wave, which should be on this level, right? So in this frame, I can re-render again to see. You can change this displacement pattern here as you want. You can reduce it. You can just change the scale of each displacement area. But again, we have something which seems good, and in general, for me, when I animated this, the level of water, I may needed to push it up a little to cover the whale. But again, because everything is interacting, if you will render this, we will see a good result which shows that the whale is doing good. So I will render this sequence from this angle or just similar angle and see what would be the results, and I will come back. So now we finished the render, and I just prepared some assets so we can continue our study here, and let's see how the animation is happening. We can go here and this and just review the results. There is a BD player from Chaos Group, and that one is so good because it doesn't have to load on the RAM, and it's very fast, and you can edit, change the exposure, do many changes much better than here the RAM player. But we will use whatever available, and from here we will analyze the movement, the look of everything. So as you can see, we have the swimming. And in this one, I just meant to increase the whale speed here to see how everything is reacting. That's important for the next scenario. As you can see, everything seems good, but of course we can increase the age or the life of each particles because they don't have to disappear exactly like this. They are really disappearing very fast. Also, for the splash particles, we need to increase their numbers, and we'll see how we can do that now. But in general, everything seems good. The only thing I can comment on is that we have bigger foam particles than it's supposed to be. We have a good number for them. I don't think we have a good number for the splashes. Else, the shading here, it looks like it's good, but I would say there's a problem here. The water is dark, and whenever I just change even the camera to top view more, it will be totally dark, and that's because of the surrounding image or environment image. If we will go here, automatically when I created the sky or the sunlight, Vray added this map, and if I will go to material, this is the map. This is actually the map. If this comes without activating the sun mode. If I will render now any frame, let's see this frame, it will look dark, and of course we can increase the intensity here by just activating this and increase the intensity, and we will have something much nicer. But let's just see what we're gonna get now. Yes, that's it. So let's introduce here the light and increase this. It's supposed to be originally 0.01. I will increase it to 0.1 and maybe 3. Let's just see how it will affect the lighting of everything. Again, this is very limited. There's no texture for the sky. If I will render, it will be just a plain sky. Its physical sky means whenever I change the light position, height, it will change. But again, it's not the kind of sky I want to deal in with my scenes. So it has a little more light, but it's not enough. So what I did is that I went here and created Vray HDRI just by going to map and choosing Vray HDRI, and I choose this image, which is basically this one, and I will attach it with project files. This is it, and this is HDRI image, which I modified a little here, but it's very good and I used it in many projects. So basically all we need to do is to convert it into spherical. Now we have this, and I can just change this number to rotate the image, and that will be reflected on the environment here. So all I need to do is to drop it here, and I can do that by just going here and drop it here and choose instance for sure, so you can change it. The only two things you may need to change is the overall multiplier for the how it's presented here in the scene, the lighting, and here of course the gamma. You can increase or decrease that to increase or decrease its intensity. So let's see how that will change things. So let's render the same frame. Now it's supposed to change something, but again we will see that when we change the camera view also. So that is a good change. As you can see, it introduced some colors here, and we see that the intensity of the light looks better now. So let's look at it from another perspective just by changing the angle of the camera. I'll just choose this and try to see it from here. I will save it first, and then we will render it, and let's just note of the horizon problems of the sea and try to fix them. It will take a little more time because now we see it closer and it's in a position which we should note all the other particles. As you can see, everything seems good, and we also see everything here. I can see that the shading for the foam and everything is good. Maybe we need to reduce the intensity of the sky a little, but it added a lot to the scene, and we can actually move our camera like this and try to see the sky itself. Now we don't have much of dark spots or dark water as we saw before, and the horizon seems nice. We can reduce the noise here by just changing few things. So first let's go to material again, and here I will do something. I will just decrease the gamma to 0.7 just to make it less bright, and I will go to the container itself and start introducing some changes. The first thing I will do is here. So we have ocean subdivision, and you know it took like with this size 10 seconds to render. So let's increase this into 4 and see the change. Now I will duplicate this image so we see the changes here in the horizon, and let's render again. This parameter gonna enhance the image here in the horizon, and it will kill some of the noise. Of course you can increase it to 6 or 8, and it will help blending this sea with the background also. See, now the sky is presented well. We can see something really nice, but again it blended everything well here with the horizon, and it seems really nice. Now let's see the horizon roughness. Of course it reduced the noise. If you notice here, here's noise more than here, so I can just change it into 6. Of course the timing for the render increased, as you notice, 2 seconds, nothing much, but all the rendering for this frame took just 10 seconds, so it's almost 20%, which we have to consider. Let's wait, and then we will discuss the horizon roughness, which here it defines how this area can be blended with the background more. Now it's rendering, and let's just note here, even better. Now everything seems smooth more, and all we need to do is to discuss the next one. I will change this to 4 again, and I will bring this to 0. Let's render this, or let's say 2, so I can compare it with this image. The horizon roughness can appear here. As you can see now, this has an end here, and you can see it, the horizon. This, it's totally disappeared. It's totally blended with the background, but also this looks like a noise. We can enhance this noise by going here to 6 and render this, but again we need to introduce some horizon roughness so it will be smooth and blended with the background as it was. Again, this will enhance the noise here. So it's finished. So as you can see, it improved a lot, the noise here, and everything is blended well. If I will introduce this again to 1, we saw the result. It will merge it well with the background. So again, I don't want to bring this up now when we are testing. I'll just keep it 2, and I'll keep this 1, and that's it for here. I think this sky is good, and we can just see other frames here as example, closer frames. I just move the camera a little here and see how that will be when just we move the camera a little. All we need to see now to separate the foam from the splash and see if we can increase the number of the splashes, because they are really few. Usually, as I mentioned, with the 10 millions almost of the liquid particles, they should be almost 2.5 million. This is my preference for the particles numbers. Now we can reduce their scale also, because they seem like one mass, but don't forget that we have motion blur also. Of course, we don't need to introduce the full motion blur here, because sometimes we need to composite this and to have additional motion blur in 2D. This is where the whale is here, and he is forming bigger splash at the beginning, but all is well and as expected. Again, let's look at it from a top view and see how we can just manage the splash increasement. That's it. So here, if I will just hide the foam and I'll just concentrate on the splash. You can hide the foam and just control it totally by hiding the icon here. Just hide it in the listener or the scene explorer. And let's go here. As you can see, we have certain number. We can come to count multiplier and increase it to 4 times. Now I have 4 times splashes. Let's see first when they are 1, like the original number, and they will be really few. As you can see here, the green dots present the splash. So we have it now. As you can see, it's very small amount. It's cloudy because if we will go here down, we see that we introduce the dots size in small size. So we can increase that, but that based on our camera, because if our camera is closed, that may look big. Again, this is in pixel. So instead, I will just increase the number to 4 times, and let's render. Let's see, here's 25 seconds. Now the time for calculations shouldn't be much different, but we see clear increasement in their number, and they are clear now. This is very nice, and I think this is what we want here. So instead of introducing the original number which we simulated, we can increase their number immediately and have them rendered, and that maybe will increase several seconds to the final render. In this case, they added like 7 seconds. Now with the foam, all we need to do is to render both together. I just activate it or just unhide it, and now we can see that everything seems good. Of course, we'll discuss more closer view of this in later stage, but for now this is what we need to know. And already we created a scene which can be the basic startup for our next scene, which is the whale coming toward the camera and creating much bigger splashes and front wave as in the cover of this course. That's it. It's rendered now, and we can see that everything seems good. Now let's jump to our next project, and in our next project it's basically the same setup. The only difference here is that we will change the whale movement. It will come to the camera, the view gonna change, and we need to introduce certain reaction for the foam. So let's begin.